Hey everyone, I'm Ren, and this is episode 7 of our Farm and G robot live stream. Here with our software engineers, Edgar and Kyle, and then we have Hector with the Amiga robot in the field at Jacobs Del Cabo in Watsonville. And Edgar and Kyle are going to take you through some app tutorials.
Hey, what's going on, everybody? Welcome to the live stream. As Ren said, I'm Kyle, and we have my screen up here. Edgar, you wanna? Oh yeah, I'm a software engineer here. Edgar, you wanna?
Yeah. So hello everyone again. I'm Edgar, one of the engineers at FarmNG, and as Ren and Kyle said, today we're working. We're gonna show some of the tutorials examples about how to develop apps with the Amiga. So I hope you enjoy this session.
Yeah, and the goal is to kind of talk through some of the concepts, show you, sort of a live demo of going through the tutorials and setting up your own app, and then kind of talk through what we did in some of the apps that are available as tutorials, so that you can kind of use that to do your own really cool stuff. Okay, so we'll start out from the website, amiga.farmandg.com. This is where all of our documentation lives, and everything that you'll hopefully want to see. Anything that's not here, ask in the discourse, and hopefully things that get asked in the discourse that weren't included in the documentation that should be here, we'll be constantly adding here. So very, very good resource. This should be the primary place that you're looking for things. There's a lot here. I won't go through all of it, but what I do want to go through, or what we do want to go through, is these tutorials. So we have some examples, both on the CircuitPython side. So these are examples that you would run on a Feather, and using the microcontroller kit that we have available on the website. Maybe I'll just show that real quick since we're talking about it. Products, developer tools, probably. Yeah, and the microcontroller kit. So the CircuitPython examples are ones that would run on the M4 Feather, the M4 CAN Feather. Then we have some examples using the Brain ADK. These are similar to the apps, the tutorials go through, but they're not built with the app template, so they're not set up to run directly on the robot. They're more ones that you would run on your laptop, connected to the robot, on the same network, and using gRPC to do those connections. And then we have the full-on tutorials. So we have sort of an introduction that goes over some concepts. We have a camera streamer tutorial, which is a really basic one, connecting to the Oak camera service and streaming those images to your app so that you have them to do whatever image processing you want to do. And then the last one's the virtual joystick, which is kind of built on top of the camera streamer, and takes it one step further by creating a custom Kivy widget for driving it around. So we make a Kivy widget, which is the joystick, and then we connect to the CAN bus to send commands and actually control the robot autonomously, or at least how you would control it autonomously. Edgar, anything you want to add there, or?
No, I think it's fine. Yeah, maybe I'm not sure if we should also explain a bit about more precisely about the brain and how is everything organized, like this microservices architecture. Maybe we can explain while we go over the examples, just for the audience to understand when we talk about gRPC services, what actually means, how the software stack is organized in the brain.
Yeah, that's a great point. Yeah, so the brain is kind of built on the concept of our services, and these are all gRPC services. So the current version of the Brain has 5 services available. One is the CAN bus service, and then we have 4 camera services, so that each camera is running independently. And you could, for instance, well, this Amiga does not have 4 cameras connected; it only has 2. So Oak 2 and Oak 3 services won't start. But if you want, you can start and stop the services independently. So if you only want to use one camera, or for whatever reason you want to turn Oak 1 off, you can turn that off while still using Oak 0. And yeah, these are gRPC services that you can connect to with a gRPC client, which is what we use in all of our apps. So the Recorder app, for instance, has a client for each of the Oak cameras, as well as a CAN bus client, and that lets it stream the data from the service, from the gRPC service. You'll see, so since we turned off the Oak 1 service, it's not available, and we have just the Oak 0 service available to us. And then the CAN bus, we don't plot the CAN bus data, we just show whether the CAN bus is in a good state and whether that data is being saved. So yeah, we have these 3 are the built-in apps that come with your Brain right now, and then you have the ability to add new apps. And I guess that ability is what we'll talk through coming up. And is there anything you want to add on those services and clients?
No, I think that it's fine for now. Maybe mention that it's not possible right now, but we are also open to hear feedback about, because we know for some use cases that you might like to create custom services. This is not a feature that we provide now, but as a team we have been discussing and waiting actually for real use cases for that. This is something that we have also in mind and we would like to explore. So feel free to reach us if you have any need in that direction.
Yeah. So if you do want to make your own services as opposed to just making your own apps and connecting to the services that we have available, let us know and we can kind of prioritize bringing that into the API, because right now it's not something that we have available. But yeah, I mean, definitely let us know things that you want as a general concept, so that we can get those things working for you. Cool. And then yeah, feel free to add in the chat, and maybe we can make sure the chat is publicly available for people who are watching, just to double check that everyone out there can chime in there, and kind of direct the conversation if they need to.
Okay, it looks like it says it's subscribers only right now. Okay.
Okay. Yeah, it looks like it's, yeah, I think you're right, Ren. So we'll get the settings changed so that people can be responding in the chat while we're going. Okay, so let's start off with going through the Brain App tutorials. So for the first one, it starts off with the Amiga App template and how to use the Amiga App template, and then some basic background knowledge of what we have going on. So there's some background knowledge of libraries that you may not be familiar with yet, but they're kind of what the Amiga App infrastructure is built around. So they're very worth getting a decent understanding on them. So the first one is gRPC, which is very well established. It's the communication protocol that we use for communicating between the services and the clients. You can make a service that does anything. It doesn't have to be directly corresponded to a specific device. It doesn't have to just be like, each camera is a service to be something as simple as like, something that pings a website or something like that. A service can be anything. We just happen to use the services for devices. And yeah, you define the communication in these .proto files, which you'll see throughout our libraries. There's a lot of documentation on gRPC that you can read through to kind of understand this. And yeah, and it's language agnostic, which is kind of nice. So if you have a Python service, but you want to write a C++ app or anything like that, then you can just communicate through these protocol buffers. Next is async IO. So this is what allows us to run multiple concurrent loops in Python. This allows, so in our instance, let's say for the virtual joystick, this allows us to have 2 while loops running forever, one that's streaming the camera and one that's controlling the CAN bus. And actually, we kind of have 3 because one is listening to the camera, one is listening to the CAN bus, and one is controlling the CAN bus. So we try to have these examples so that you can, clearly see how to use the async IO library for creating these additional tasks. Do you want to talk about Kivy, Edgar?
Yeah, so the next library that we leverage here, at least for the brain, is the Kivy. So Kivy, it's a Python library that allow you to create these nice graphical user interface apps that you are seeing exactly in your Amiga brain. So it's kind of nice. Maybe Kyle, if you want to open the website of Kivy.
Mm-hmm.
So Kivy, yeah, it's a very complete, I guess, framework. I'm not sure it's, how they call it, but it's kind of simple to start just creating an app as you were creating a phone app. Probably you noticed that in the brain, we have been very inspired by phone apps, the camera app, the gallery, what we call the launcher, but it's also discrete to open the apps. It's with Kivy, it's kind of easy and nice to design these apps. Yeah, so as Kyle is pointing out, Kivy, they have their own language, the Kivy design language. Yeah, we highly recommend to check this website. So, well, in the next example, this template example, we have a very minimal example how to leverage this combination of Kivy language and Python. But it's worth to check all the tutorials. I will say at first it's not super straightforward, but yeah, the more that you check their examples, etc., you will understand that you can really create very good looking applications.
Mm-hmm. For sure. And just to reiterate, all 3 of these libraries, the gRPC, async IO, and Kivy, are all huge, super popular Python libraries. They're not like specific to FarmNG by any means. They're just what we chose to use. So like learning them and understanding them is going to be super helpful for you and like what you do in the future as well. Yeah, and then last would be the FarmNG libraries. These are some of our open source packages that you can install with pip. And FarmNG Core is a little more back-end kind of things. You probably won't be interacting with it too much, although you can, of course. And then that is used by FarmNG Amiga, and FarmNG Amiga is more the API that you will be interacting with. Simple pip install, just like any pip package, FarmNG Amiga. And then we have some examples in here, some Python examples that are also linked on the Amiga FarmNG, Amiga.FarmNG this folder, and you can kind of look at what's available there. For instance, like the stream frames method. This is just a wrapper on the stream frames RPC call. So this sort of just like abstracts it away a little bit for you. And what I mean by the stream frames RPC call, maybe I'll keep that open and I'll bring a new tab. Side by side. So this is defined in the proto definition. Proto. So these are different RPCs that you can access. So the main one that you'll be using is stream frames. So you can see that RPC stream frames is what is called by the stream frames method. If you wanted to get the camera calibration, you could use the get calibration RPC, where you would send a get calibration request for the camera. And these are all proto defined messages that you can see in the same file, and then it would respond with a get calibration reply. So yeah, this is what's happening here is on the get calibration, for instance, if you call that request, your client will send the get calibration request to the camera service, and then the camera service would reply with the get calibration reply. The stream frames, you'll see that there's this keyword stream on the server side. So that means that it's a server streaming RPC. You can also, whereas the get calibration is a unary RPC where it's only one request and one reply, you could also switch it where the client is streaming and the service only sends one reply, or you could have them both streaming bidirectional. So yeah, the gRPC documentation talks through this. The core concept explains it pretty well. So yeah, definitely read through their docs, but just kind of to give a little context in our application. Okay. Then we can move on to the template. I guess should we set up the template first or talk through it and then set it up, do you think?
I think that we can show first to anyone where you can find the templates, just very quickly show the structure, maybe the project. And
yeah. Okay, yeah, that sounds like a good idea. So a good place, and I'm sure it's linked down here somewhere, or we can use the cool search bar. So developing custom applications is the what explains how to use the Amiga app template. You can find it in the general bar. So you'll go examples. Sorry, it doesn't work as well on the tap screen. To the examples, and then it's one of the sections in the examples. And this talks through how to use the Amiga app template. So in order to put an app on your robot, on your Amiga and have it available to use, which right now you'll see on the Amiga, it only has the 3 basic apps. It doesn't have any of our additional applications developed on there. You'll clone that app onto the Amiga. So for instance, you could clone the camera streamer or the virtual joystick, one of our 2 example applications on there, or you could create your own app. When you do clone these apps onto the Amiga, you clone them into the apps directory. When you're SSH'd into the Amiga, so I can kind of show, I'm going to SSH into the Amiga, which screen I'm showing. And you'll see there's an apps folder in the home directory. If I just do ls here, you'll see we have this apps folder, and that's where any apps that you want to clone will go. You can clone apps directly into there. So if you wanted to clone the virtual joystick, you could, let's see, let me do a little, move this one over here. So if you want to install the virtual joystick app, for instance, you can copy, I'll probably use HTTPS, and you can go to the apps directory, hit clone, paste that path in there. And then if you watch the screen, let's see, we should have that pop up. Oh, wait, there it was. Okay. Internet might be a little slow. So this is the robot that's out on the farm right now. And I'm connected to it remotely. So you'll see that the virtual joystick app popped up automatically. And then if you want to run it, you can click the button. The first time you run an app, it's going to install everything. So this is going to be kind of slow the first time. So another option is to launch it manually from the command line with the entry.sh script, which is basically what hitting the button calls. And yeah, again, so the first time you run an app, it installs all of the pip dependencies in your package. So that might kind of take a while. So we can let that run in the background and move on to the app template. So if you want, so yeah, so you can clone one of the available apps there. We're hoping that kind of with this open source community there, we develop like an ecosystem of apps where other people are creating apps as well that you can install on your Amiga and kind of build a community that way. And in order to make your own app, you'll follow the instructions here and create an app, which will start off with using the Amiga App template. There's a nice little GIF here showing how to set one up. So we will go full screen here. We'll use this app template, create a new repository. You can set it as either public or private. Totally up to you on how you want to do that. I guess here we'll go public. And we'll do custom app demo is what we'll call it. Recommended to use dashes or underscores. Don't use spaces in your repository names. And actually, I'll go private because there's one thing that this will. If it's public, then anybody can clone it, and you don't need your Git credentials to clone it. And maybe that's one thing that people will get hung up on is getting their Git credentials confirmed when it's private. So we'll show how you can use that. So now I have this private repository. Nobody else can clone it, only me. Called custom app demo. We can losing my tabs. So after we've made that, I can either clone it directly onto my laptop and edit it there, or I could clone it directly onto the Amiga and develop on the Amiga, which is a pretty cool way of running. And by the way, the virtual joystick finished installing, and now the app is running.
Yeah, actually, Kyle, you said something. Sorry. Yeah, Kyle, you said something interesting here that you can run the apps in your desktop also. So the cool thing about Kiwi, we use it to run the apps in the robot, but ideally, you could run the same apps in your computer. So Kiwi allows that, to deploy kind of everywhere the apps, and sometimes it's very useful. We use sometimes this feature to debug, for example, some apps in our computers and then connect through the gRPC. So it's also recommended like to try this feature. This template app, it's you can run it also in your computer and start iterating on that.
Yeah, and I guess I could, okay. So now that we have this private app, in order to start out by developing directly on the robot, you can use VS Code to manage like everything for you. Highly recommended to develop this way. There's one, so you can install different extensions. There's one extension that you'll want. It's called Remote SSH. SSH.
Yeah.
Remote SSH. There we go. Typed it right. So this extension will allow you to open a VS Code terminal on your Amiga. Once you have that installed, in the bottom left corner, there's this little green square. And when you hover over it, it's open a remote window. If you have other extensions installed that use that square, you might have other options. But the one that you want is connect to host. In here, you can connect to, so I'll connect to Amiga at Iron Apple, which is the name of the robot. Or alternatively, were I on the same network as the Amiga, I could do Amiga at 192.168.100.247. So for you, how you'll probably connect is you'll use that IP address instead of the name, because you'll be on the same network. I'm just developing remotely, so we're using Tailscale to handle that for us. Are you sure you want to continue connecting? Continue. And then you can enter your password. Okay, so now, if I go to, and I'll just kind of show, if I go to this repository and I try to clone it, I don't have my credentials on this robot. So I would have to put in my username and my password in order to clone. If I use HTTPS and if I use SSH, I think somebody has an SSH key on this robot, but it's not me. So if I try to clone, because it's a private repository, you have to put in your credentials. So I can't clone directly. If you want to do that from the command line, GitHub, create an SSH key. You'll need to generate an SSH key and then add it to your account. And their documentation of this is very clear and works quite well, but it is more difficult. So you'll generate it and then you'll add that new SSH key. And that totally works. But with VS Code, there's a much easier way to do it, which is if you Control-Shift key, and that's like the bring up special commands. You can also find it other ways, but you could type in git clone. You'll see that it has a git clone feature. So now if you have your git credentials set up on your laptop, VS Code can use those, and you can clone. So this is an SSH terminal in the robot using the git credentials from my laptop so that I don't have to also put them on the robot. And I can put up my new repository. What did we call it? Custom app. Custom app demo. So I can put that and custom app demo. And I'll clone it into apps. Maybe I'll bring up this screen so you can see we don't have the app there. I can go okay. Does not exist. Did I type it wrong? Let me get the name. Here we go. Okay, cool. Yeah, I guess maybe it just needed to search for it first. So now that's cloned that onto the robot and you can open the robot. I'm sure you want to continue. Sure. Use a password. And yes, I trust the authors. So now we have custom app demo cloned onto the robot. So if we check in here, we'll see that it's in our folder. And if we check on the home screen, we should soon have that appear. Oh, Yes, I keep
Yeah,
jumping the gun
yeah.
just a little bit. One thing is so the buttons are created when it detects the folder in the apps, and then the image is added based on whether there was an image in that apps folder. The first time you install an app, sometimes the folder clones, but the image doesn't. The little app icon hasn't downloaded in time. So for now, there's just a little button where you can refresh the app buttons on the settings page, and then that will cause them to refresh and check for the image that is now downloaded. And so now you see we have our little app icon. Okay. So now we have our app directly on the robot that we can run. But before we do that, we'll make a few changes. So we will go through and we'll change the name. Or maybe, do you want to talk through the structure first, Edgar?
Yeah. So when you create a new repository based on the template tab, you will see mainly this structure that we show here in the documentation. So this is just a very minimal skeleton where, so we'd recommend to first, before start running or moving things around, it's recommended to check, understand the internals of the repository. And another thing to learn here is that we are leveraging the Python packaging tools, basically setup tools. So in the end, a Kiwi app, well, Amiga Kiwi app, it's just a Python standard Python package and follow the same rules as the standard packaging. So, and as you see here, we have like 1, 2, 3 main directories, and then there is the entry sh and setup config. The entry sh, I think that Kyle mentioned before, it's the entry point of the app. So this is it's a bash script that when you click on the screen, actually we are just calling that shell script, and this will start the app and show to you on the screen. If you are developing in the terminal, you could do the same. You could just call the bash script, and you will start the app from your command line. Yeah. Maybe now, Kyle, you can show the content of the setup config file.
Yeah.
So this is kind of the package definition. As I said, we are just following Python standards to create the package. And I'm pretty sure that somewhere in the documentation, we have the link of the structure of this file. But in any case, the important part here is the metadata section, where you should define, well, you can redefine the name of the package. You are also able to version this package, change all this metadata. Some things that you should also be aware of is in case you want to add new dependencies. So the dependencies section, it's this first block starting in line 18. The install requires, it's actually what you are interested in. So if you see here, this app right now depends basically on Kiwi, because we're using the graphical user interface with Kiwi, and then the PharmG Amiga, which is the gRPC client libraries. But if you would like, for example, yeah, Kyle is reading my mind, use OpenCV. You just need to add here OpenCV or other libraries if you're doing, yeah, or machine learning, there are other libraries. If you're doing machine learning, I think that you will have to contact us because, for example, things like PyTorch or TensorFlow we are still testing all these. Coordinates another alternative to OpenCV using PyTorch. So yeah, if you are willing to use these libraries, I think that probably you will face issues. So it's worth to contact us, and we'll be very happy to enable you to use these libraries. So this is the section you will define your dependencies, and when you call, or the system calls the entity.sh, will first parse this file, check all the dependencies, install your dependencies. And then besides that, I think that we recommend to not touch that many things unless you are kind of expertise a bit the setup tools packaging, because all the definitions after line 31, 32, it's how we are assuming that the package will be organized. So yeah, we recommend to not touch that much. If you are doing, or you need, or you have a specific use case, I think we'll be very happy. We encourage you to just write in Discord a message explaining what do you want to achieve, and then we can definitely guide you.
Mhm.
Apart from that, this is kind of the main thing. Then in terms of coding, we have these two directories called libs and source. So in source, it's, as we said, this example relies on Kiwi. This main script, Python script, it's, you will see this template app, which is the base class that we put together. If you see, it's a class, a subclass, the Kiwi app class, and then we have just the skeleton for you, how to start the app. Right now, it's a very simple counter based on the clock, internal clock of the app. So and then basically something that we also recommend, as we were saying before, is that so in the way it's a structure, this app, usually you will have the Python definition side to the Kiwi language definition. The Kiwi language definition is this main.kv, that stands for main Kiwi language. And the way we have defined it now, we recommend that you abstract as much as possible all the visual parts, the definition of the QI layout in this Kiwi language file. And the cool thing, as soon as you dive into the documentation, you will see that it's kind of easy to interact from the Kiwi language and the Python definitions. I think another feature that we added here, it's we recommend, if you are using or want to implement like pure Python kind of internal libraries, we enable this libs directory, where you should put here, we added, implemented for you this kind of as a function to add just two numbers that later you could use in the main class of your app. This is kind of a good practice to separate basically what's the Kiwi app versus your pure Python implementations. That's kind of I think the overall. I'm not sure if I'm missing something, Kyle, or some comments you want to add.
No, I think you hit the full structure. Yeah, I think that was good. Yeah. So we'll show you how to.
Also something important. We added also this test directory with a test. We highly recommend also to attest in your apps, yeah, just to verify that you don't have bugs, etc., that everything is working properly. So yeah, we encourage you to do yeah, test development based.
Yeah. Okay. So as yeah, now that you have a good idea of the overview, we can show what changes to make in order to set your app up. And again, just following this section, customizing an app. So what you'll do is instead of using the Amiga package library name, which is sort of the template, you'll change that to whatever you want to call your package that you're creating. So here I might do, might call my new package, I don't know, custom app demo, since that's what my library or my repository is named. Then anywhere where you previously found Amiga package, you should replace that with custom app demo. So that'll be anywhere it's imported. So that'll be in main.py. I'll go full screen here so you can see a little better. In main.py, you'll rename that package, and then as well as in your test. So you can just replace all of those. And then the libs folder, you're creating this library Amiga package, you'll need to rename that folder to match. And so now you have your own Python defined package. You can of course rename these links to match the actual source. Not a huge deal, but it's kind of cool to do since you are, creating a Python package. And this will be for the Amiga Robot. Okay, so once that is all set up, then we'll just double check, but I think then you're able to, oh yeah, and then also you add the dependencies in setup.config, which we showed already. So we've added OpenCV Python and PySerial as dependencies. Once you've done that, you're ready to run your app. There's two ways to do it again. I could click on custom app demo, the app icon, or I could run it with the entry.sh script, which I'm going to do in this case so that you can watch the installation process in the terminal. But again, this is identical to just clicking the button. So now it's going to create a virtual environment where it will install all of these dependencies. I guess maybe OpenCV was a little bit heavy of a dependency to add. It might take a little longer to install than some of the lighter packages.
Well, something useful also when you start the app with the terminal, in case you are in development or debugging mode, is that you will get also all the prints and logins in your terminal. It's a nice feature also to be aware of.
Yeah, that's a great point. Yeah, so maybe for development mode, that should be kind of the recommended way to run it, is so that you can put debug statements and things like that in there. Okay, now it's installing some FarmNG packages. It's installed Kivy. Now it's building the package, the custom app demo package. And pretty soon it should be launching. Okay, there we go. So now you have a Kivy app that you've defined running on the brain. If you do launch it again, if you add any dependencies, it'll install those dependencies. But if the dependencies haven't changed, the next time you launch it, see how much faster it launches. And same thing with using the button to launch. It launches right away. Now you can edit the code directly on the robot. Where did my wrong window? You can edit the code directly on the robot. So in main.py, if you wanted to make a change, I don't know, just change the way it prints slightly, tick, tick, and tack, tack. Then launch that on the robot, and you should see that effect take place.
Well, maybe something cool that we could show is how to debug from VS Code.
I think we're short on time. If we want to, let's that'll be a good follow-up one though.
Yeah.
That's a good point. Oh, also somebody added in the chat, and that's a good point. Kivy even works on your phone. So you can make Kivy apps for iOS and for Android. And you could have you could create apps where your phone is communicating with the brain, and use Kivy to define both of them, which is super cool.
Yeah. We haven't tried yet, but yeah, we encourage everyone like to try it. And yeah, let us know. It could be a very good community example. Just a Kivy app in your Android or iPhone, just streaming the camera and sending some commands to the Amiga. That would be super cool.
Yeah.
Yeah. Yeah, and well, referring to the debugging, since we don't have time, but I think it's worth to say that as soon as we are working with Visual Studio, it's kind of easy, to go in the debug mode and just start the app. I'm not sure right now if it should be directly the entry.sh or the main Python file, but we have tried for sure. Maybe we can just dedicate another session to that. But the cool thing is that you could start in a remote session with the debug mode and just add breakpoints to any part of your code and just use the VS Code debugger to just debug or.
Yeah, and we'll save going in depth because there's some environment set up, and you can like specify your arguments and things like that once you have command line args. Okay. The last page of the tutorial introduction is kind of going a little more line by line through the tutorial. Maybe we won't talk through it too long, but just showing the imports. There's some Kivy configuration that needs to happen. And this is kind of an important thing that's described here is you'll need to bring in the Kivy config and set it before the rest of your Kivy imports, because some of the other Kivy imports are then modified based off of the config. So keeping this order and then adding any additional Kivy imports you want to add after these is important. Then we have the definition of our super simple Kivy app from the template. We use a relative layout, which lets you position different widgets everywhere. Kivy is sort of defined by, you'll have your app, which is running everything, and then you have layouts. And inside those layouts, you have widgets. And so everything kind of falls into those categories, at least on more basic Kivy usage. So for instance, label is, if you want to print text, that's a widget. Button is also a widget, and that has built-in definitions that you can find in the Kivy API. And then those are both set in this relative layout. You can also nest layouts, so you could have a sub layout inside your relative layout if you wanted to have like a box layout or a stacked layout. And these are all things you'll see that we use in our examples, as well as pretty well defined in the Kivy API and documentation. So this kind of explains all of those. We also add this back button, which is how you exit the app. That's an important thing not to delete, because if you're running on the screen and you launch your custom app, if you don't have a way to kill that that process, then you're going to be stuck with the app running. So
Yeah.
keep this back button that's part of the app template in all of your apps. You'll see that we have it in the virtual joystick. You could modify it if you want, but definitely keep something there that lets you close the app so that when you're running it on the brain and not from the terminal, you can actually kill it. Yeah. Do you think we have time to go into streaming, Edgar? Or do we need to spin off into another another live stream? I guess we went pretty thorough on the app template setup.
Yeah. Yeah, I think that maybe we can just show a bit how to use the virtual joystick, the one we started, and yeah, just to serve an example, a proven example that this is actually working, right?
Yeah. Yeah. Do you want to go there or camera streamer?
Well, let's take the virtual joystick maybe, since we are kind of a bit of short in time, and we have the virtual joystick already installed and running.
Okay, so I'll switch over to the virtual joystick. I do trust the authors. And I guess as we're going through this, we'll just note that the camera streamer is a simplified version of the virtual joystick that only shows how to do the camera stream. So that is included in this.
Yeah.
So yeah, maybe on the tutorial page, it talks through how it starts, talks about setting up the template, just like we just went through, and then goes through the device stream. So the camera stream is exactly the same as in the camera streamer tutorial. And rather than just looking at the docs, we'll actually show you where that's implemented. You'll see we added some Kivy imports down here, some additional ones like string property and texture weren't in the app template. And then other imports up above, just for formatting. For these tasks, these forever running tasks, we create a list of async IO tasks. And this is where your task that, like your while loop that's streaming the camera, or your while loop that's streaming the CAN bus, that's where these will go. And these are defined in the app func, which app function, which runs is like kind of what kicks off actually running the in the main function. Down below, you'll see we run until complete, which is async IO library commands. So we run the app function basically until it's killed with the back button or Control C in the terminal. In the app function, we add these forever running tasks. But first we configure the client. So we set up the client config for the camera, which is passing an address, which is the IP address basically of the robot. When it's running on itself, it can just be the local host. If you are running from your computer, you can set the IP address of the Amiga and it'll connect to it over gRPC. And then the port, the camera ports are, I think, 50051, 50052, and up, and the CAN bus port is 50060. These are documented and talked about in the example. And I think you're probably, okay, so they're not set as default arguments. So if you look at entry.sh, we pass those values in there. Okay, sorry, focusing on the stream. So we configure the camera client and we configure the canvas client with those addresses and ports. Then we create the tasks that are going to run forever. So one of the tasks is this stream camera function that we define below. And then for the CAN bus, we have one task for streaming the CAN bus messages and another task for sending CAN bus messages. So all three of these tasks are while loops that run forever that can run concurrently because we're using the async IO library. The stream camera, we will look through this. Oh, that's CAN bus. Stream camera. Okay, so you'll see there's a little bit of boilerplate in these stream tasks that are sort of like, necessary safety and setup. Self.root is a Kivy definition. So basically we want to wait until the Kivy app is up and running before we start going into setting up the camera stream. So that's what this little safety kind of sit there and wait is. Once the Kivy app is running, we get into the forever running while loop. And Edgar, please feel free to jump in at any time. So for every loop of this, we check the state of the client, which is what you see on the screen here on basically like the left of the service is the color code indicating the client state. So the CAN bus, the OAK0 and the OAK1 are all idle. OAK2 and OAK3 are unavailable. Other states are running, which is when it has a client connected to it. And there's also an error state, which occasionally you might get on your CAN bus if like a bad actor CAN device gets on the screen or gets on the bus, in which case you'll just stop and restart the CAN bus service. So we check that state. If the state is not idle or running, which means it's not available, we basically are going to not continue on the loop. We're not going to try to listen to the camera stream. We only want to listen to the camera stream if it's idle or if it's running. If it is not in those states and it was previously in those states, then you'll have a response stream, and we want to cancel that so that we can recreate it when the service is up and running again. Next, okay, so we've passed that if it's idle or running, so we know that it is in an okay state. It's either ready to be streamed or it is streaming. Then we can create the response stream if it's not there. We use the client, which is the OAK camera client, stream frames method, which, if you recall from earlier in the live stream, just wraps the stream frames RPC call. So we send it a stream frames request, and then it'll start streaming a stream frames reply back to us. So this response stream basically is a gRPC. I guess maybe you could think of it as a generator, a Python generator, where anytime the OAK camera service gets an image from the OAK device, it'll put that image on to the queue, and then our client can grab that message off of the queue. This await keyword is a async IO library, so that basically when we get here, we want to wait for the next image to be available. Until that image is available, we release the thread so that we're not doing anything, and we're not blocking other functions from running. Yeah, basically we just sit there doing nothing and let other tasks run on your computer, release the resources until there's an image ready. Once that image is ready, we now have a response, which is an OAK stream frames reply, which is a proto definition. And I guess I could, where would this be? Amiga. Is that the proto definitions?
Yeah, in the OAK proto, maybe.
Yeah, nice. Okay. Okay, so again, we're using this stream frames RPC call. And this is the oak.proto from PharmNG Amiga. It's in our virtual environment now because they've installed PharmNG Amiga. We send it that stream frames request using the client stream frames call. And now we're getting a stream of stream frames replies. So if you looked at the stream frames reply, it is a message that contains one oak sync frame. If you looked at the oak sync frame, that contains a left image, a right image, an RGB or a color image, and a disparity image. If you've configured a neural network to run on the oak cameras, which is a really cool thing you can do with them that we won't get into, you'll also get that, and then you'll get the IMU data. Basically, there's a little bit of try except safety here that prevents your app from crashing if something happens with the gRPC communication, or if the server decides that it's the end of the stream. Once you have that, you can extract the oak sync frame from the response. So again, stream frames reply, this was our response. It has an oak sync frame, which is known as frame. So that's where we do response.frame, gives us that oak sync frame. Then we can go through that oak sync frame, and we can get the RGB view, the disparity view, the left view, and the right view. So you'll see that those names here match with the names here. So basically, we get those images. We use our image decoder to decode the images. And then we add these to our tabbed panel of image views. So maybe we can go line by line and say what's happening. Okay, so first the proto message, the image that comes in. So we are taking the frame view name. So that would be, let's say we're using RGB. So we have oak sync frame.rgb is an oak frame. The oak frame has some metadata, and then it has the image data, which is in bytes, just raw bytes. So we take those raw bytes, and those are what we pass to the image decoder in order to get the actual image. Then we create a texture, and this is a Kiwi texture that will be the right size of the image. The flip vertical is oh gosh, I don't remember why we added this. I think it's if the images coming upside down or the textures upside down.
Yeah, I think it's more. I think it was something from the camera.
Okay. Yeah. And then we add the image into the Kiwi texture that we already created, so that the image data is now put into this texture so that it can display. And then the texture that we created, we pass it to, so self.root is the Kiwi app that has some IDs, which are, let's go to main.kv and show this. So the Kiwi widgets, they all have a field called ID, so that you can reference them. So self.root.IDs is anything with an ID in main.kv will be accessible that way in kind of like a dictionary lookup. And so we're doing the root.ids.rgb since it matches the view name up here. And then we are setting the texture of the RGB view on the tab panel to be the texture that we just created and put the image bytes, the decoded image bytes into. And then we can virtual joystick, run that. Bring up the screen. And so that's where we get these. So we have we have a tabbed panel with 4 tabs, an RGB, a disparity, a left to right. And we are decoding the data that came from the canvas server or the camera service into here. Yeah. Anything you want to add on that, Edgar?
No, I think it's fine. Yeah, just to remark that, yeah, the image data coming from the the camera services, they all come, as you said, as bytes, which means we receive JPEG compressed image. So yeah, so every time that you want to visualize or do any image processing or computer vision, anything on images, you will need to decode the image in the JPEG format. Yeah, and here you are showing, right?
Mm-hmm.
We implement this library called Turbo JPEG, which is a quite fast library to decode in JPEG format. So yeah, we also encourage you to use that for performance.
Mm-hmm. Yeah.
Cool.
And my headphones just died. Can you hear me?
Yes.
Okay. So yeah, I think we're already over time, so maybe we wrap it up, and maybe we'll have to do a part 2 in the near future. I encourage you to check out the stream canvas method or function and see how basically everything, you know, down to the try except is almost identical because this is like the managing the connection of the gRPC client to the gRP server. And then the last little part on the bottom is where you do different things based off of what type of message you have. So here, since we're looking for a specific Canvas message in order to extract the speed and the angular rate and the state of the Amiga, we parse for those messages, whereas for the camera, because all we wanted to do was display them, we decoded them and then added them to the TV, the correct TV widget. If you wanted to instead do some image processing, instead of doing all of this texture work, you would, sort of like insert your OpenCV image processing here, kind of thing.
Yeah, and also from the Canvas side, worth to mention that we recently added a more high-level API, the Twist API. So that basically will kind of allow you to easily just stream directly the linear and angular velocities of the robot, and also at the same time send commands. Yeah. So yeah, this virtual joystick app, I think it's one of the first ones we used. We created before we had this high-level API. So it's internally this API, it's kind of wrapping what you can see in the virtual joystick to decode and encode the Canvas messages, more specifically to this high-level API format. Yeah.
Awesome. Absolutely right. Besides getting the control state, the Twist API has all that information, and it is a little cleaner and easier to interact with. You could use this stream vehicle twist state, server streaming RPC. You would send a stream vehicle twist state request, which is just an empty message, but you're required to send something. And then you'll get a stream of stream vehicle twist state replies, which will have a stamp saying what time it was received from the canvas, and then this twist 2D message, which has a linear x velocity, a linear y velocity, and an angular velocity.
Yeah, I
And
think that this API we can cover in the next session. Probably the one that we were discussing to implement this controller using the Xbox control application. I think that's it will be more clear if we spend some time on that. I think it's not a different way to see it.
that sounds like it. Yeah, we should do that. That's a good idea for next week. All right. Well, I think we should finish up 11 minutes late.
Yeah,
Thank
like you're gonna go for it, Kyle.
No, Ren, this is all you.
Yeah, like, comment, subscribe. We'll see you guys tomorrow for number 8, showing off some navigation in the greenhouse, and maybe Kyle has something extra for us too. We'll see. Thank you guys.